Hello and good day, geometry. Going over CO34 using proportions. We're kind of easing into this unit on triangle similarity. Yesterday we talked about ratios, which are it compares two parts of a whole. And today we're going to talk about proportions. And we can use proportions to find angles and sides of similar figures. But before we start, we're going to kind of review how to solve a proportion. Okay, these three examples here are all proportions. If you recall from sixth grade math, probably, proportion is simply two equivalent fractions. So you can fill that definition here. Two equivalent fractions or rates, since a rate can be written in fraction form. Okay, a proportion are two equivalent fractions or rates. And when we don't know one part of the proportion, what are some methods that we can use? There's kind of one standard one that you learn like 5 different ways to solve a proportion. There's one that most people kind of hang on to, so it works every single time. It's nifty. Peter? Cross products, right? And the whole deal with cross products is that the product of the numerator of one and the denominator of the other, 2 times n, will be equal to the product of the numerator of the other times the denominator. Okay? So 2 times n equals 9 times 5. You solve this. 2n equals 45. And n equals 22.5. It's not often we get decimal answers, especially with like these introductory things. So how would you check this to make sure that you're right? What are some different ways you can check it? Anyone remember? Peter?
Plug the number back.
Sure. I mean, you could plug the number back in. Does 22 times 22.5 times 2, does that equal 45? Okay. What's another way you could do it? Kind of going back to the original proportion. If 22.5 is our value for n, that means that the fraction 2/9 is equal to 5 over 22.5. How could you confirm with a calculator? How would you confirm that those two are equivalent? That proportion is true? Anyone know off the top of their head what the decimal value of 2/9 is? Or calculate it in your calculator? Caleb?
Oh yeah, I don't know what the question was, but wouldn't you be able to divide 22.5 divided by 9 to get what you're multiplying by across?
Yes. So one way is to see if the scale factor between your numerators and your denominators is consistent. So if you take 22.5 divided by 9, and then take 5 divided by 2, you should get the same number, which ends up being 2.5. So that's one way to do it. Okay. What's another way? Going back to my original question, what's the decimal value of 2/9? Drew? 0.2 repeating. We'll just round it to 0.22. What's the decimal value of 5 over 22.5? Anyone have a guess?
0.22.
0.2 repeating. Yeah. Okay. So with proportions, the two fractions or the two rates will have the same decimal value. So this is a really neat way to quickly check your answer. Make sure you are right. Caleb brought up a second way of comparing scale factor. That works also. Whatever floats your proverbial boat. Okay. Next one. We've got n times 78 or 78n equals 13 times 36. What'd you get? Who is confident in their work and their answer? Multiply 13 times 36, what is 13 times 36? Peter?
468.
468? Okay, divide both sides by 78, and you come up with, Peter again?
6.
6? That's much more friendly. Okay. And then you could compare that. Does 6/13 equal 36/78? You can use scale factor, right? 6 times 6 is 36, 13 times 6 is 78. That works. 6/13, whatever nasty decimal that is, it'll be the same thing as 36/78. You can simplify 36/78 down to 6/13, right? There's lots of ways to verify that these two, in fact, are equal or are proportional. But cross products is a good method to use there. You're all probably eyeing the last one, though, okay? When you've got that other stuff, right? N plus 9 over 2 equals 5n minus 3 over 4. We're still going to use cross products here, but what do you have to include in your equation here to make sure that you're going to come up with the correct answer? When we multiply, for example, n plus 9 times 4, what do we have to make sure that we include? Parentheses, right? It's not just 4 times n plus 9, because in this case, we're only multiplying the n by 4. We want to multiply n plus 9 by 4, right? So ensuring you got parentheses there, okay? And then the next one, 2 times 5n minus 3, same kind of thing. Parentheses around that 5n minus 3. So it means you're going to have to distribute. 4 times n plus 9 gives us 4n plus 36 equals 10n minus 6. So not only do we get to distribute, we get variables on both sides. It's just a fantastic algebra proportion to solve. If you move your constant to the left, add 6 to both sides, that gives you 42. Subtract 4 from both sides, you get 6n. And you get a value of 7 for n. I went through that fairly quickly, but any questions on that process? Should be review, most of it, right? Checking this, you can do it the same as you did the other ones. Plug 7 in, and we get 7 plus 9 over 2, or 16 over 2, is equal to 5 times 7 minus 3 over 4, or 32 over 4. And you can see that 16 over 2, which equals 8, is equivalent to 32 over 4, which also equals 8. Okay? Total waste, excuse me, total waste of your time going through that, or was that kind of helpful? Yeah. All right, well now I can say I did it. So then if you need it, then at least you have it here. But getting into the crux of it here, okay? Using proportions to solve for missing sides of similar figures. We talked yesterday about how similar figures, it means they are proportional. Okay? Not congruent, not same size, same shape, but proportional. Same shape, different sizes. Okay? So it says, what proportions can be written? Use them to solve for x. Give me one possible proportion you could write using these figures that would allow you to correctly solve for the variable. I'll give you a hint. You're going to be using corresponding sides. Okay, there's a couple different ways to do it, but there's a certain order that needs to be followed here. All right. For example, if I start by setting my 8 over 10, kind of that horizontal side of each shape there, that corresponding sides, MN corresponds with RS, 8 over 10. What would the second half of this proportion be? What would the second half of the proportion be? Yeah, Drew.
4 over x.
Right, 4 over x. Why couldn't I write x over 4? What would the problem with that be? If I write 8 over 10 equals x over 4, what's the problem there, Drew?
Sides aren't corresponding.
Sides aren't corresponding. They're corresponding, but I didn't start with the same figure each time. It kind of goes back to slope, right? When you use two ordered pairs to solve for the slope, you have to kind of do the same order. Whichever ordered pair you start with for your first calculation, you have to use that same ordered pair to start with for your second one. Same thing here. Could I also write 10 over 8 equals x over 4. That would work, right? If I start with my figure on the right, 10 over 8, again start with my figure on the right, x over 4, that would work out as well. Okay? What's another possible proportion we could write here? Joey, you have a guess? You look like you kind of, what?
8 over 4 equals 10, correct?
Yeah, you could also go within the same shape, right? In these first two here, I went from one shape to the other. Joey's saying, well, we can also just take 8 over 4, stay within the same shape, then go to the next one. What would the fraction be for the second half of this proportion be? 10 over x. Again, kind of lining up those corresponding sides. What's the other option here? What else could I do? Will. 4 over 8. I'm smiling because I've seen Encanto so many times in the last three weeks that when I ask what else can I do in my head, I go, bring it in. Right? 4 over 8, what's the second half of this?
Oh,
No? You haven't seen Encanto? It's a great movie. I mean, having young kids at home and needing sleep, Okay, anyway, 4 over 8, what would the second part of this be? Match those corresponding sides. 4 over 8 equals what? X over 10. Okay, so these first two that we have on the left here, they go from one shape to the other. The second two on the right, we kind of stay within the same shape. The first fraction involves one shape, the second fraction involves the other. But the reason why these all work is, what do all of these have in common? When we go to use cross products to solve for these, what do you notice? Just kind of mentally use cross products on all 4 of those proportions there. What do you see happens? Joey?
You always end up with the same 2 numbers.
You always end up with the same products, right? In each of these, you always end up with 8 times x equals 4 over 10. 8 times x equals 4 over 10, or 4 times 10. 8 times x here, and 8 times x here, right? That's why they're all eligible proportions, because cross products is going to be the same for all of them. You get 8x equals 40, and ultimately x equals 5. Okay? Questions on that so far? Okay. The next figure, we kind of have a triangle inside of another one. And in this case, it's going to be helpful to separate these. My advice to you, whenever you've got a shape inside of another one, is if you're able to separate them. Let's draw the green triangle here, okay? And we'll make this a larger one. We'll make it a red one here, right? And make our larger red triangle here, right? And let's fill in sides here. What do we know as far as side lengths for the green triangle? What's this bottom side? Anybody? The bottom side of the green triangle. Anybody? Just say it. 12. Okay? Labeled here, right? What's the diagonal side of the green triangle? Anybody?
18.
18. Okay? What's that left side of the green triangle? What this is saying is that x is from here all the way down to here. But the distance from D to A is 3. What would that mean the length of that left side of that green triangle is? X minus 3, right? It's the whole thing minus the part that's not the green triangle. So this would be x minus 3. And then how about the red triangle? What is what's the diagonal side length of that red triangle? Joe?
Oh, isn't diagonal like that?
This right side here. I can't call it a hypotenuse technically because it's not a right triangle, but the longest side of the triangle.
24.
24, right? 18 for the green plus an extra 6 gives us 24. What's the length of the left side of the red triangle?
X.
X, right? The X refers to the whole thing. Do we need the bottom side if we're going to use a proportion to solve for the variable here? No, we don't need all 3 sides of the triangle. We only need 2 of them. So this 12, well, don't want to say it doesn't matter. It doesn't matter. Okay? We don't need that bottom side. Give me a proportion we could set up to solve for X here. Think about corresponding sides. Think about what order you want to put things in. Do you want to jump from one triangle to the other, or just stay within the same shape? You've got a lot of options here. Mackie, give me one.
X minus 3 over 18, and then X over 24.
Good. Okay. Why that works is we're starting with the, I'll call it vertical, but it's not quite, but the vertical side of our green triangle, X minus 3 over the diagonal side, and then doing the same order with the other shape. The vertical side X over that diagonal side 24. That would work. Okay. What's another possible proportion you can set up? Joey, you said you were going to say something? What proportion were you thinking of?
24 over x equals 18.
Sure, you could go the other way. You could flip this upside down. Do it. Okay. Again, stay within that same shape. Anyone see anything else? If you jump from one shape to the other, you could do perhaps X minus 3 over X, that vertical side of the green shape over the vertical side of the red shape, equals the diagonal side of the green shape over the diagonal side of the red shape. And the reason why this works is, again, look at cross products, it's going to be the same calculations. Either way, when we use cross products, we are multiplying X minus 3 by 24. Make sure you got your parentheses there. And we're multiplying 18 by X. It'd be the same calculation if we did it over here. X minus 3 times 24, and then 18 times X. Do a little bit of distribution. 24x minus 72 equals 18x. I'm going to run out of space, but ultimately, what does x equal? Those that have done the work and solved it. Blake?
12.
That's what I got too. X equals 12. Right? We could check that. Check that by plugging it into either of our proportions. Does 12 minus 3 over 12 equal 18/24? Or does 9 over 12 equal 18/24? Yes, it does. So we're good. Okay. I'm hearing a lot of chatter, a lot of whispering, which tells me that you understand it.
Yes.
Okay.
Totally.
All right. If you understand it, then feel free to participate. So just get through it fast. Okay. Are there any questions? Okay. Your assignment then for tomorrow. Let's see what 6-1 and 6-2. I have 2 sections to choose from. That's exciting. 6-1 and 6-2. Oh, okay.
Joe's trying to get
Okay, folks, listen up, please. On page 367,
No.
I would like you to do 11 and 12. And 16 and 17.
Come on, man.
So much.
That's two more.
You've been spoiled with all these Google quizzes. Let's be honest. You've
I
been
don't think so.
spoiled.
Let's do them all.
Well,
it's not our fault you want to keep.
Google. No, it's not your fault. I'm not saying it is, but you don't think so. And that's all. However, hold on. You do need to show your work. Show me what proportion. Schlafer, did you get that? Show me what proportions you are using to solve. Okay? Work must be shown. Work must be shown. You got 9 minutes to work on it now. That is how you math.
Don't like